Hello everyone, welcome back to this video series on clinical SAS Adam programming. In this video, we will see another example of date imputation. So here we will be imputing dates, imputing missing date components based on treatment start date of the subjects. So basically overall we will try to push the partial date as close as possible to the treatment start date. So we will now see the specification for it. So here the specification is written more in a kind of programming approach kind of thing. So we'll see that. So it says create temporary variables as indicated below. So create a character variable named AEST year by extracting the year portion from AESTDTC. So we are creating a separate variable for year of adverse event start date. And then similarly, we are creating a variable named AEST underscore month by extracting the month portion from AESTDTC, and then a character variable named AEST underscore DAY by extracting the day portion from AESTDTC. Basically, we are segregating the year, month, and day components from AESTDTC and storing them in three separate variables, all of them having a prefix of AEST underscore, and the variables are AEST underscore year, underscore month, and underscore day. Similarly, create a character variable named TRTST underscore year by extracting the year portion from TRTSDT. And similarly, we are being asked to create TRTST underscore month for storing the month portion from TRTSDT, and then TRTST underscore DAY by extracting the day portion from TRTSDT. So we have segregated the year, month, and day of adverse event start date, year, month, and day of treatment start date as well as the general processing. And then the actual derivation begins here. So step A involves, it says when date collected is full, which means when AESTDTC is full, so convert to numeric format directly. Then the section B, it says when year and month is available and day is missing. So year and month is available and day is missing. So again, this involves three steps. The first one says if adverse event start year is before treatment start date year, then use last day of the month for day component and convert it into numeric value. Let's say the treatment start year is 2012. And if the adverse event started in 2011, say for example November, so we are being asked to use the last day of November for populating the adverse event start date. And else if AEST year is after treatment start date year, then use first day of the month for day component and convert to numeric value. If the year is before, then we are using last day of the month. If the year is after, then we are being asked to populate with the first day of the month for the day component. Else if AEST year is the same as treatment start year and month is before treatment start month, so then use last day of the month. So if the adverse event started before the treatment start month, so then we are being asked to use the last day of the month. And again, if year is same as treatment start year but month is same as treatment start month, so then use treatment start date for day components, which means so the day component from TRTST has to be used for imputing the day component when year and month is same as the year and month of treatment start date. So else if AEST year is same as treatment start year and AEST month is after treatment start month, then use last day of the month for day component and convert it to numeric value. When only year is present and month and day are missing. So if AEST year is before treatment start date year, then use last day of the year for month and day components and convert it to numeric value, which means last day of the year and would be 31st December. Else if AEST year is after treatment start year, then use first day of the year for month and day component, which means 1st Jan has to be used for missing month and day components. Else if AEST year is same as treatment start year, then use treatment start month and treatment start day for month and day components. Say for example, if treatment started in the year 2012 and if partial date is only present as 2012, so we'll have to use the treatment start date for imputing. So this kind of looks a little complex, but when we look at the data scenarios, we'll be able to easily flag it. So then we have the derivation for ASTDTF. It says set to M when month and day components are imputed, else set to D when day component is imputed. Now we will take a look at the input data that we will be using before we move on to the programming. So we will be using our adverse events dataset as input. So here we have USUBJ ID, AESTDTC and treatment start date given. So if we take a look at AESTDTC values, we have some full dates and some partial dates with only day missing and some partial dates with only year present. So we will now go ahead and see how to program for the specification provided. So here I am using a dataset as input and creating a temporary dataset called AE01. And then I'm using AE01 to create a dataset called AE02. As per the specification, so we had to make many comparisons between start year of adverse event and start year of treatment start date and month of adverse event versus month of your treatment start date. So for all those, we are creating temporary variables. As per the specification, we were supposed to create 3 variables, year, month, and day for adverse event. So we are doing that here. So in the first line, so we are creating AEST underscore year. We are making use of scan function on AEST So we are saying that I want the first word when hyphen is the delimiter. We know that as per ISO 8601 notation, so we will have the date in 4-digit year separated by hyphen and 2-digit month separated by hyphen and then 2-digit day. So the first word when hyphen is the delimiter will be equivalent to our year. So we are extracting first word when hyphen is the delimiter and storing that in AEST underscore year. And then we know that second word when hyphen is the delimiter would be equal to our 2-character month. So we are extracting that month and storing in AEST underscore month. And finally, the third word will be our day component. So we are extracting that using scan function again and storing it in AEST underscore day. So we have created the 3 temporary variables for adverse event start date as per the specification. And then we were also asked to extract year, month, and day components from treatment start date. But here AEST DTC was a character variable, so we were easily able to apply scan function to extract the words. But treatment start date, which comes from ADSL into our individual adverse events analysis dataset, so that is a numeric value. So in order to extract the month, year, and day from numeric date values, we have separate functions. So we will be using them here to create those variables. So here we are creating the variable TRTST underscore year by first extracting the year component from TRTSDT. So we are applying year function on TRTSDT. So it returns the year and then that year we are converting it into character format using put function and 4 dot format. So we are making use of year function to extract the year from numeric date value. And then we are creating TRTST underscore month variable. So similar to year function to extract the year component from date, we have function called month to extract the month component from numeric date value. So we are applying month function on TRTSDT. So and that returns the numeric month value. And then we are converting it into 2-character wide string using put function and Z2 format. Say for example, if the year corresponds to if the month on this TRTSDT is of Feb, so it would simply return the value of 2. So if we directly convert it into with put function, it would not have that leading 0. So we are adding that leading zero using Z2 format. And then similar to year and month functions, we have a function called day function to extract the day component from numeric date value. So we are applying day function on TRTSDT. So this would return our day value from the numeric date value, and then we are converting it to 2 character wide character string using put function and Z2 format. And then we are converting the numeric TRTSDT to a TRTSDTC using YYMMDD 10 dot format in put function. So a character variant of treatment start date is created and we are calling it as TRTSDTC. So we have created temporary variables as suggested in the specification. So now we'll have to jump into the actual programming for ASTDT creation. So the first part of the specification said when the date is full. So we will know that date is full, we'll have full 10 characters in your AESTDTC. So we are making use of length function to check the total number of characters reported in AESTDTC. And if it is equal to 10, which means the overall full date is present. So in that case, so we are directly creating AESTDTC by simply applying input function on AESTDTC using YYMMDD 10.in format. So this converts the value present in AESTDTC to numeric date value and assigns to ASTDT variable. So one part of the specification creation is handled now. That was part A, I think. So we have converted the full dates to numeric. And then comes our cases where we only have year and month reported. As per ISO 8601 notation, so when we have year and month only reported, the overall number of characters in AESTDTC would be 7. So we are checking if length of AESTDTC is equal to 7, which means only year and month are reported. So in that case, so we are simply assigning D to the ASTDTF, which means we are imputing day here. And then comes our individual conditions that we have to check for under when only year and month are present. So if ASTDTC is equal to sub-strn of TRTSDT 1 to 7. So from the treatment start date, so we are extracting the first 7 characters. So this is, we have converted TRTSDT to TRTSDTC, so which is a character version in YYMMDD 10 dot format. So if we take a quick look at the data, we'll get a better idea. So let me go to AE02. So we have created all these temporary variables AEST underscore year underscore month underscore day, and similarly we created year, month and day for treatment start date, and then we created TRT SDTC. So in this TRT SDTC, the values are present in YYMMDD 10 dot format. So we are extracting the first 7 characters of it, so which is year and month are being extracted. So now let's go back to the code. So we are checking if the reported partial date, which only has year and month, is equal to the year and month of the treatment start date. So if that was the case, so we were asked to populate the ASTDT by using the treatment start day component. So here, say for example, if we again, let's go back to the data. So here, if we see this case, 2010-03, the total number of characters is 7. This record meets the condition which we are checking for currently in the program. So we have 7 characters here, and then we are checking if this is equivalent to the first 7 characters in TRT-SDTC. So if that is the case, so we were asked to use the value from TRT-ST day and then create our ASTDY, which means so we'll have to concatenate this 15 to this existing ASTDTC and then convert to numeric value. So we are doing that here now. So ASTDTC input of cat s of ASTDTC concatenate with the value present in TRTSDTC. So if this is true, so if it is year and month is same of adverse event is same as year and month of treatment start date, and when we have upfrontly checked whether it is a partial date or not. If that is the case, so we are using the day component from TRTSTDY and temporarily making that character value and then converting it into numeric value using input function. So temporarily concatenate as the first argument of input function and then use that resulting value to create ASTDT. So this completed one part of the derivation. So when year and month of adverse event start date is same as the year and month of uh, treatment start date. And then in the next case, so we are checking if year and month of AESTDTC is greater than sub-STRN of TRTSDTC 1 to 7, which is after the month of treatment. So if this is the case, we were asked to populate with 0, 1. Now let us go back and then see if we had a scenario for this. So the date should be partial and it should be after. So the treatment start date is 15th March 2012. So there should be a date in 2012. So we do not have any such case in data, but again, as per the logic, so here if we see if it is after, then as per the specification, so let me come back. If AEST year is same as treatment start year and month is after the month, then use last day of the month for day component. I think there is an issue in the specification here. I'll try to correct this in the website after making this video, but this should be the first day of the month, because if it is happening after, we want to push the partial date to the imputation which is close to the treatment start date. So that will only happen if we use 01 for this, which is first day of the month. So I'll try to correct this post making this video. So this should read as first day of the month. So here we are checking if AESTDTC is partial and then if it is after the month of treatment start and month. So we are supposed to use the value of 01. So we are concatenating the value of 01 to the existing date value and then converting to numeric format using input function like in other cases. And then in the next case, so we are checking if AESTDTC is less than or is equal to the treatment start date and month. So if it is happening before, so we are supposed to impute it with the last day of the month. So let's see if we have a use case in data. So March 2012, do we have a case partial date in 2012? Yes. So Feb 2012. So we have a partial date and then this year and month is before the year and month of treatment start date. In this case, so we were supposed to populate it with the last day of the month. So the last day of year 2012 is 2000, 2012 is as it is a leap year, it is supposed to be 29th Feb. So we have to populate ASTDT as 29th Feb. Let's see how that is actually handled here. So here we are making use of another function called intnx function. So intnx function actually returns a date value by a pre-specified interval. The next date value uh, when we specify the pre-specified interval. So here we are making use of intnx function. We are saying that I want the next date to be reported in terms of month from this so and so partial date from this date, and then I want the return date to be the end date from the month. So here when AESTDTC is less than or is equal to sub STRN of TRTSDT 1 to 7. So I am checking whether it is before the start year and if year and month of adverse event start date is less than year and month of treatment start date. So what I'm doing here is I am temporarily creating the start day of the month. So we already have year and month. So I am temporarily assigning concatenating 01 to it, which means it will become first day of that month and then converting it into numeric format. So till here I will have a numeric date value created. So from that numeric date value will be used. So I am saying that I want the next interval to be reported in terms of months, but increment it by zero interval, which means the same month, but return the end value in that month. So when I have 2012-02, so temporarily I am making it as 1st Feb 2012. So and then I am asking it to return the next month value. So in terms of zero increment. So the zero increment stands for the same month. So 1st Feb, same month, return the end date value. So it knows that the in 1st Feb, as it is Feb 2012, the end date is to 29. So it would return me the value of 29 Feb 2012. Say for example, if it is 2010-02, so what would this temporary value will become? So it will become 1st Feb 2010, and then I am asking the month value to be incremented by 0 months. So 0 months. So which means same month, but return the value, end value from that month. So which is in 2010 Feb, which is a non-leap year. So it will only have 28 days. So it will return the value of 28th Feb. So we are temporarily making use of the concatenation of 0, 1 to create start date of that month, and then making use of month in the first argument, and then 0 in the third argument, and e in the last argument to get the required end date value on a particular month. So, and then we'll move to the next case. Else if length of AESTDTC is equal to 4, then do. So when only year is present, so we are imputing at both month and day. So if that is the case, so we have to check for three conditions, whether it is the same year, whether it is before or after the treatment start date year. So in the first condition, we are checking if adverse event start year is greater than treatment start date year. So if it is greater than, which is after the treatment start year, so we were asked to use the 1st Jan. So we are concatenating 0101 to the existing year value in AESTDTC and then converting it into numeric format. And then else if it is the same year, so we were asked to use the value present in TRTSDT. So we are using that here. Else if AEST year is after treatment start year is less than treatment start date year, which is prior to the treatment start year. So we were asked to use the 31st December value for month and day component. So we are doing that here by temporarily concatenating 31st December here to the existing year value in AEST DTC and then converting it into numeric format. So this completed our imputations. So let us now take a look at our output dataset and then see how this actually worked. So here we have our AE02 dataset. So let's go to AE output dataset and check each individual record. So here AESTDTC is full, so which means it has to be directly converted to numeric value. So 1st March 2012, so we have AESTDTC as 1st March 2012. So 3 2012, which means March 2012, so it is equal to the month and year of treatment start date. So when that was the case, so we were asked to use the day component from treatment start date, which is 15th. So 15th when associated to the 15th March 2012, so it will become 15th March 2012. So this is coming as expected. And as we are only imputing day component, so ASTDTF was supposed to be D here. So it is coming correctly. And then, so we have here Feb of 2012. So here it is prior to the treatment start date month and year. So which is March 2012 is the treatment start month and year, but this is Feb. So which means it is prior to it. So if it was prior to it, so we wanted to bring the date as close as possible to the treatment start date. The date as close as possible to the treatment start date would be the last day of that month. So which is 29th Feb. So we got it. So and here we have a next case. So where we have a partial date, but here the year is 2010 and Feb again. So when it is prior to, when the year of treatment start date is prior, so we were asked to use the last day of the month again. So the last day of the month is in Feb 2010 is 28th Feb. So we are getting that correctly here. So that was the advantage of using int_n_x function. So we need not check whether the year is a leap year or not, whether what month is it kind of thing. And then we have this year as the partial date, only 2012 is collected as this is equivalent to the year of treatment start. So we were supposed to use the treatment start date because that was the closest date to the treatment start date that we can build with the known partial date. So here 2010, so 15th March is supposed to be the ASTDT. So we have that here. And then 2011. So this is prior to the treatment start year of 2012. So the closest date in year 2011 to the treatment start date of 15th March 2012 will be the last day in that year. So the last day in year 2011 will be 31st December. So that was supposed to be the ASTDT. So 31st December 2011. So and then we have a next date value which is January 2011. So the closest date value prior uh, to the treatment start date. So this partial date is before treatment start date. So the closest date in 1st Jan 2011 to the treatment start date is 31st of January. So we are getting that correctly here. And then we have a full date of 1st Jan 2011. So as we have full date, ASTDT should actually reflect the same date. So which is coming correctly 1st Jan 2011. And then we have a partial date of 2010, 2013. So which is after the treatment start year. So the closest date that we can build for year 2013 to the treatment start date is, as this is after, the closest would be the earliest date, which is January 1st. So 1st Jan 2010 is supposed to come. So we are getting that here. And then we have December 2013. So as this year is after treatment start year, so we'll have to bring this close to the treatment start date. The closest date in December 2013 to the treatment start date of 15th March 2012 is 1st of December. So we are supposed to get that here. So which is coming correctly here. And then we have 17th December 2013. So which is a full date. So there should be no imputation and the ASTT should reflect the same date value, 17th December 2013. And then we have another case in Feb 2016. So this date value is after treatment start year of 2012. So as this is after, so we want to push the date as close as possible to the treatment start date. The closest to the treatment start date when the adverse event start date is after the treatment start date would be the start day of that month. So here the date value should be 01. So this is a very complex date imputation that we have actually done here. So hopefully you should have got some understanding on how this can be done. Thank you for watching and keep learning.